circles and the angles formed by radii, chords, secants, and tangents. Stop this video at any time to review the concepts for a longer period of time, or to look carefully at the examples and how they are worked. There also may be stop signs at points where independent practice problems appear. Our first type of angle formed by two radii is called a central angle. A central angle is an angle where the center of the circle is the vertex of the angle, and the sides of the angle are radii of the circle. The arc formed by the intersection points of the radii and the circle is called the intercepted arc. The measure of a central angle is equal to the measure of its intercepted arc.
Take a look at these examples and how the solutions are obtained. In the first example, the measure of the central angle is 130 degrees. Since the measure of a central angle is equal to the measure of its intercepted or minor arc, the measure of arc XZ is also 130 degrees. In the second example, the intercepted or minor arc is 88 degrees. So, since the measure of arc XZ is 88 degrees, then the measure of the central angle XYZ is also 88 degrees.
Next, we will look at the angle formed by two chords that intersect on the circle. This is called an inscribed angle. An inscribed angle is defined to be an angle formed by two chords that intersect on the circle. The measure of the inscribed angle is half the measure of its intercepted or minor arc.
Let's look at some examples. In this first example, the measure of the inscribed angle is 55 degrees. Since the measure of an inscribed angle is half the measure of its intercepted arc, then arc XZ is twice or 2 times 55 degrees, or 110 degrees. In the second example, the intercepted or minor arc XZ has a measure of 162 degrees. Since the measure of an inscribed angle is half the measure of its intercepted or minor arc, then the measure of angle XYZ is half of 162 degrees, or 81 degrees.
Now work on some problems on your own. Stop the video here and work the problems given.
Let's see if you got these correct. The measure of angle XYZ is equal to 145 degrees. In problem number 2, the measure of angle XYZ is equal to 49 degrees. Finally, the answer to number 2 is 80 degrees. You did great. If you missed any of these, go back in this video and review the definitions and sample problems.
Now let's look at angles formed by chords which intersect inside the circle. The arcs formed by the chords are the intercepting arcs for the angle. Arcs WX and ZY are the intercepting arcs for angle WBX. The measure of angle WBX is half the sum of the intercepting arcs, or in this diagram, arcs WX and ZY. The measure of an angle formed by two chords intersecting inside the circle is equal to half the sum of the measures of the intercepting arcs. In this diagram, the measure of angle WBX is equal to half the sum of the measures of arcs WX and ZY.
Now, let's look at more examples. In example number 1, the measure of angle WBX is half the sum of the measures of arcs WX and ZY. So the measure of angle WBX is half of the sum of 55 and 85 degrees. 55 and 85 degrees add to 140 degrees, and half of 140 degrees is 70 degrees. In the second example, you first must find the measure of the angle ZBY. Since angle ZBY and angle XBY are adjacent angles that form a straight line, the sum of the two angles is 180 degrees. The measure of angle XBY is 63 degrees. To find angle ZBY, subtract 63 degrees from 180 degrees, and you get 117 degrees. Then the measure of angle ZBY is equal to half the sum of the measures of arcs WX and ZY. We know that angle ZBY is 117, so plug in what we know. 117 degrees equals half of 202 degrees plus the measure of arc WX. Solving the equation for the measure of arc WX, 234 is equal to 202 degrees plus the measure of arc WX. Subtract 202 degrees from both sides, and we get 32 degrees for the measure of arc WX.
When a chord and a tangent line or segment intersect on the circle, the measure of the angle is half the measure of the intercepted arc. The intercepted arc is the arc formed between the point of intersection of the chord and circle and the tangent point. So, the measure of angle ABC is equal to half the measure of arc AXB.
Here we are with a few more examples. In the first example, the measure of angle ABC is equal to half the measure of the intercepted arc. So, the measure of angle ABC is half of 240 degrees, or 120 degrees. In the second example, we must find the intercepted arc for angle ABC. We know that a circle is 360 degrees, so the intercepted arc is 360 degrees minus 280 degrees, or 80 degrees. Now that we know the intercepted arc for angle ABC is 80 degrees, we can find the measure of ABC by dividing 80 in half. So the measure of angle ABC is equal to 40 degrees.
Now work on some problems on your own. Stop the video here and work the problems given.
Now let's check your answers. In the first problem, you should have gotten 80 degrees. For the second problem, you should have gotten 66 degrees. And finally, for the last problem, you should have gotten 190 degrees. You did great. If you missed any of these, go back in this video and review the definitions and sample problems.
Finally, let's look at the angles and arcs formed when two secant lines or secant segments intersect at a point outside of the circle. The measure of the angle formed by two secants intersecting outside the circle is equal to half the difference in the intercepting arcs. In the diagram given, the measure of angle DAE is equal to half the difference in arcs DE and BC.
In this first example of our last group of example problems, you need to find the measure of angle A. The measure of angle A equals half the difference in 102 degrees and 68 degrees, or half of 34 degrees. So the measure of angle A equals half of 34 degrees, or 17 degrees. In example 2, again we know that the measure of angle A equals half the difference in arcs DE and BC. Plug the values into the equation and solve for the measure of arc DE. So, 50 degrees equals half the difference of the measure of arc DE and 85 degrees. 100 degrees equals the measure of arc DE minus 85. Add 85 to both sides and you get the measure of arc DE equals 185 degrees. In the last example, we want to find the sum of the other two arcs on the circle. The measure of angle A equals half the measure of the difference in measures of arc DE and BC. We must first find the measure of arc DE. As with the previous problem, the measure of angle A, or 65 degrees, equals half the measure of the difference in arc DE and the measure of arc BC, or 99 degrees. Solving the equation for the measure of arc DE, we find that the measure of arc DE equals 229 degrees. So, since a circle is 306 degrees, we subtract 229 degrees and 99 degrees from 360 degrees and get the sum of the remaining arcs DB and EC is 32 degrees.
Now work on some problems on your own. Stop the video here and work the problems given.
Now let's check your answers. In the first problem, you should have gotten the measure of angle A equals 25 degrees. For the second problem, you should have gotten the measure of arc BC equals 33 degrees. For the last problem, you should have gotten that the measure of angle A equals 27 degrees. You did great. If you missed any of these, go back in this video and review the definitions and sample problems.
This video has been the production of DNJ Designs and Math Man 1962. If you like this video, please click the like button. If you want to get more of these videos, please click the subscribe button. If you want to be notified when new videos have been posted, please click the bell button.